we go, students, to the homework help video, page 172. Let's go ahead and get started. Here we go. Numbers 3 through 83, every other odd. Now, first of all, the directions for number 3 say to find the real numbers a and b such that the equation is true. Now, here we go. A minus 1, there's a positive sign here, so multiply that through, and you're left with A minus 1. There's also a positive sign here. If you multiply that through, you're left with positive B. I made a mistake, sorry students. There is a positive sign here in front of this parentheses. There's also an I right here. Now my advice to you is to put the I right here. It's easier to see that you're multiplying it through, okay? So that's my suggestion to you. But if you don't like that, you're welcome to first multiply a positive sign through and then the I. So positive times B is positive, and I times B is IB. So positive IB. And actually the B should come first, so BI. And then positive times positive is 3 times I is positive 3I. Okay? Now, let's see if we can figure out what A and B have to be to make these two sides be equal over here, okay? So here we go. We have A minus 1. Now, A is a real number. And then we have negative 1, which is a real number, okay? So what would you have to put in for A right here to make this whole thing here become 5? Well, would it not be 6? If you put a 6 in for A, you would have what? 6 minus 1, which would give you what? 5. And that's what you want to have, is a 5. So what does A have to be? 6. So up here I'm going to write A equals 6. Now, what does B have to be? Well, let's think about it. I want to have an 8I, correct? I already have a 3I here. So what would you have to put for B right here? So that when you took this number plus this number, you got 8I. Would it not be a 5? If B was a 5, you would have 5I plus 3I, which would give you 8I. And of course you want to have an 8I for the two sides to be equal. So what does B have to be? 5. So B equals 5. So there we go. Just a little simple problem to start off there, where we're trying to find out what A and B would have to be to make both of these sides equal, okay? Alright, moving on to number 7. Numbers 7 through 15. The directions say to write the complex number in standard form, okay? Write the complex number in standard form. And so here we go. First of all, we're going to write 2 minus square root of 27 and then put an I. So I made the negative sign a positive right here and put an I on the outside. Now next, we can break up 27 into 9 times 3. Okay? So cross the 9 off and put a 3 on the outside because the square root of 9 is 3. So now we have 2 minus 3 square root of 3I. So here's your A, here's your B, and there's your I for your imaginary part of the complex number. Okay, so there we go. Alright, let's take a look at number 7 in the back of the book. And yes, that is correct. Alright, number 9, or number 11. Now students, I want to be very clear. We just have a real number 8. You're more than welcome just to put 8 and circle it. I don't care. Some books would want you to put 8 plus 0I so that you have your A right here and your B here. As you can tell, they're both the same. I'm really not concerned. You may write this in in standard form, like this or like this, okay? Alright, number 15. Alright, now first of all, the simple thing to do is to make this positive and put an I on the outside. So now we have square root of 0.09I, okay? Now, if you type this into your calculator, it's actually a perfect square, okay? Because 0.3 times 0.3 is 0.09. So the square root of 0.09 is 0.3. And then bring down your I, and look at that. There's your complex number written in standard form. Now, to be honest with you students, some books and some teachers, since there's no A term, they want you to put 0 plus 0.3I. So you have your A here and your B here. You're welcome to do that. That's fine. I would not make you do that. 3i is totally acceptable. Alright, let's move on now to numbers 19 through 25. Or 19 and 23, excuse me. We're either going to perform the addition or subtraction and write the result in standard form. Alright, and so here we go. Number 19, we have a positive sign here and a negative sign here. Multiply your positive sign through. 8 minus I. Take your negative sign, multiply it through. Negative times a positive. Negative times a negative. Now combine your like terms. A negative I and a positive I cancel out. 8 minus 4 is 4. So again, you're welcome to write your answer like this. If you want to put this, that is totally acceptable also. I have no preference at all, okay? Alright, number 23. We simply have a 13i here, so bring that down. And then we have a negative sign, so multiply the negative sign through. Negative times a positive. Negative times a negative. Now, here's an imaginary number, positive 13, positive 7. And then don't forget that your real number goes first, so negative 14 comes first. And that's complex, that's standard form of a complex number, okay? Alright, moving on to numbers 27 through 39. The directions say to perform the operation and write the result in standard form. And so here we go. I forgot to check these past ones. I really want to make sure we're doing these right. I don't want to make a little mistake. This is right, and this is right. Okay, here we go. Now, first of all, remember, you must always make the negative signs positive first. So make it positive, put an I here. Make it positive, put an I here. That's the first thing you must do. Now multiply the two radicals together. 6 times 2 is 12. And of course, I times I is I squared. Now, 12 can be broken down into 4 times 3. Cross off the 4, put a 2 on the outside. The square root of 4 is 2. So we have 2 square root of 3 I squared, which is really a negative 1. So 2 times the square root of 3 times negative 1 is just negative 2 square root of 3. Okay? And to be honest, students, you would have not have gotten this answer like this if you would have first multiplied these together, because negative 6 times negative 2 is a positive 12, and you would have ended up with 2 square root of 3, and that is not the correct answer. Always make sure you get rid of your negative radicands first. Alright, number 31. Okay, we're multiplying two complex numbers together. Take your 1 and multiply it through. 1 times 3 and 1 times negative 2i. Now take your positive I and multiply it through. I times 3. And positive times the negative is negative. I times 2i is 2i squared. Now students, we know I squared is negative 1. Okay? And negative times a negative is a positive. Now let's combine like terms. 3 plus 2 is a positive 3. 3 plus 2 is 5. Negative 2 plus 3 is a positive 1i. You do not need to put that 1 if you don't want to. So there we go. There's the standard form of a complex number. Alright, 5 plus I. Number 35, same thing again, only we got some square roots thrown in, so really be careful and follow what I do here carefully, okay? Square root of 14 times square root of 14 is 14, and then square root of 14 times a negative. Square root of 10i would be, well, positive times a negative is negative. 14 times 10 is 140. And then, of course, I, okay? Now, I took this, and by the way, notice you're multiplying conjugates, okay? So your middle terms here and here are going to cancel out, okay? Just want to point that out to you. Alright, now let's take our positive, square root of 10i, multiply it through. So positive times the positive is positive. Square root of 10i and 14 would be the square root of 140i. okay? And then positive times the negative is negative. Square root of 10 times square root of 10 is 10. And then I times I is I squared. Now these cancel out, students. So you're really left with 14 minus 10I squared. Now that I squared, as we know, is a negative 1. And so, a negative times a negative gives you a positive 10, which gives you, finally, 24. Now, if you want to put 24 plus 0I, please feel free to do that. You're also allowed just to leave it 24, okay? And that's number 35. Let me check the book. That is correct. Moving on to 39. Okay, this will be a little bit of a pain, but we're okay. First of all, we're going to take 2 plus 3I times 2 plus 3I. We're squaring them, okay? So it's 2 plus 3I times 2 plus 3I. Now, students, this is pre-calculus class, so I'm going to go pretty fast through, okay, guys? There's really no need not to, okay? You guys should be able to handle that pretty well. So if you take your 2 and multiply it through, take your 3I and multiply it through, you end up with 4 plus 12I plus 9I squared. Okay, of course I squared is a negative 1, and a positive 9 times a negative 1 is a negative 9. Combine your like terms. 4 minus 9, negative 5 plus 12I. Okay, so when you took this times itself and you squared it, you got this, okay? So what that means is this entire first expression here, 2 plus 3I squared equals this here. Now, bring down a positive sign. And now, let's go ahead and take 2 minus 3I and square it. So 2 minus 3I times 2 minus 3I. And here we go. 2 times 2 is 4. And of course, you'd have a negative 12I. And then a positive 9I squared. Alright? Now, I squared is a negative 1. And 9 times a negative 1 is a negative 9. 4 minus 9 is negative 5. So we're left with negative 5 minus 12I. Okay, 4 minus 9, negative 5 minus 12I. Now, there's a positive sign here that we brought down, so multiply that through. Negative 5 plus 12I, negative, positive times a negative, positive times a negative. And we end up with, hopefully, we've not made any mistakes anywhere. We end up with negative 10 because these cancel out, and you're left with negative 10. Now, if you want to put plus 0I, that's fine, but you do not have to. All right? Okay, moving on to number 43. Okay, the directions for numbers 43 and 47 say to write the conjugate of the number, then multiply the number by its conjugate, okay? So, I'm going to go ahead and show you guys a shortcut here that will save time on these. So the conjugate of negative 1 minus the square root of 5I, the conjugate would be negative 1. You don't change the sign of the first number, plus square root of 5I. Now, you're multiplying a binomial times a binomial. And here's the shortcut I want to show you. Remember, during your notes I taught you that whenever you multiply two conjugates together, the middle terms cancel out. So to save time, can I teach you a shortcut, guys, you're going to like? Whenever you're multiplying conjugates, just multiply the first term times the first term in each parentheses, and then the last term times the last term, and you're finished. You can always do that when you're multiplying conjugates. So negative 1 times negative 1 is 1, and then a negative times the positive is negative. Square root of 5 times square root of 5 is just 5. Okay? I times I is I squared. Alright? Now, I squared, of course, is a negative 1, so we really have a negative 1 here. Negative 5 times negative 1 is 5, plus 1 is 6. So there we go. When you multiply these two conjugates together, you should get 6. Alright? Okay, moving on to number 47. Well, now be careful on the conjugate of 8 here. Okay? Be really careful on this. I want to draw your attention, students, to this back here, on this problem here. Notice whenever you're writing the conjugate of a complex number, the complex number is written in standard form. So if it's written in standard form, your imaginary number comes second. Got it? If your imaginary number comes second, then your imaginary number is the number that you change the sign of, because you always change the sign of the second number. Well, here, are we given the real number or the imaginary number? Well, you know it's not the imaginary number because there's no I with it. So this is the real number of a complex number. So you really could put square root of 8 plus what? 0i. So in other words, the sign you would change would be the 0i, making it negative. There's no need to put a 0. I'm just trying to show you, you do not change the sign of this because it's not the imaginary number part, it's the real number part, okay? So, to be honest with you, the conjugate of the square root of 8 is just square root of 8. Multiply them together and you get 8. In case you're confused here, guys, let's just pretend we had an imaginary number like 3i, okay? And I said write the conjugate of this, okay? Well, if you look at standard form, that would be standard form, okay? Now you don't need the 0, but notice when you write it in standard form, this is your second term, and you always change the sign of your second term. So the conjugate of 3i is negative 3i. And of course, if you multiply them together, you get 9, negative 9i squared. Put a negative 1 here, you would get 9. So you're always changing the sign of the second term. And by the way, is it really that important, Mr. Hart? Yes, it is, because later on we're going to learn a rule that says whenever you have an irrational number for one of your zeros, its conjugate also exists, and you have to know how to write a conjugate, okay? Alright, moving on to number 51, okay? We're now going to simplify some fractions with complex numbers. Remember, you multiply the top and the bottom by the conjugate of the denominator. So the conjugate of the denominator is 4 plus 5i, and we also write that up top so that we're multiplying this fraction right here by the exact same thing to the top and the bottom, okay? So with that in mind, here we go. Your numerator would have 2 times 4 is 8, 2 times 5i is 10i. Now in the bottom, in your denominators, you're multiplying conjugates. And I just showed you a shortcut. Whenever you're multiplying conjugates, multiply the first term in each parentheses, and then multiply the second term in each parentheses, and you're finished. So 4 times 4 is 16, and a negative and a positive gives you a negative. 5 times 5 is 25. I times I is I squared. Okay? Now, students, where the I squared is, you put a negative 1. And negative 25 times negative 1 is a positive 25. So now we have 8 plus 10i over 41. And now we write our answer in standard form. 8 over 41. Then bring down the sign here. Plus 10 over 41i. Okay? So that should be the answer for number 51. Let's check and make sure that it is. And yes, it is. Moving on to number 55. Okay, now remember, this is your B part, or the second part of your complex number. So you do change the sign of this. So you multiply the top and the bottom by negative I over negative I. The conjugate of I is negative I. So 6 times negative I is negative 6i. Negative times a negative is a positive 5i squared. Now, I squared is a negative 1, so you really have 5 times negative 1, which is a negative 5. Now, I times negative I is negative I squared. So you really have a negative and then a negative 1. So your denominator becomes a positive 1. So really, if it's over 1, then you're finished. Your answer is negative 6i minus 5, okay? And that's number 55. I didn't write that in standard form, did I? My fault. Not a very good example. It would be negative 5 minus 6i. There we go. Number 59. Now, students, notice here that we do not have common denominators. Okay, we do not. So there's a couple of different ways to do this. Okay, you can find a common denominator for the two fractions to put them together, or you can quickly simplify each fraction, which is the route I'm going to go, and then combine them. Okay, so I really have 2 over 1 plus I, and I'm going to simplify this fraction by multiplying it by its conjugate, 1 minus I over 1 minus I. Okay, I can do it really quickly. 2 times I is 2. 2 times negative I is negative 2I. Now in the denominator, you're multiplying conjugates, so use the shortcut. First term times first term, 1. Last term times last term, negative I squared. Now, you only have a negative 1, which makes it a positive 1, which gives you a 2 for the denominator. Okay? So you end up with 2 over 2. Then take your sign here, minus 2 over 2i. Okay? And 2 over 2 is 1. 2 over 2 is 1, so 1 minus 1i, or just I. So this entire expression here, I simplified it, gave me 1 minus I. Got it? So this entire fraction here is that. Now, let's go ahead and simplify this fraction over here. So 3 over 1 minus I, multiply it by the conjugate, 1 plus I over 1 plus I. 3 times 1 is 3. 3 plus I is 3i. Now, first term times first term, you're multiplying two conjugates, so use your shortcut. First term times first term is 1. Last term times last term is negative I squared. That's really like having a negative 1, because I squared is negative. So we have a positive 1, which gives you a 2. So 3 plus 3i all over 2 gives you 3 over 2 plus 3 over 2i. Okay, so this entire expression here is what this entire expression right here is. And then bring down parentheses around this, and bring down your negative sign. So here we go. There's a positive sign here, so 1 minus I, and negative times a positive. Negative times a positive. And here we go. 3 halves is 1 1/2, so 1 minus 1 1/2 is a negative 1/2. Now I have a negative 1 here, even though you can't see it. So a negative 1 and a negative 1 1/2 is a negative 2 1/2, okay? Negative 2 1/2. And of course, 2 1/2 is 5 over 2, so negative 5 over 2i. And that's number 59. Hopefully we did not make a mistake. No, we did not. We are good. Moving on to number 63. Now in number 63 through, let me look at my book here, 63 through 71, they want us to use the quadratic formula to solve. The reason they want us to do that is they want us to see what to do when we get negative radicands, I'm pretty sure. So here's the quadratic formula, in case you've forgotten that. Negative b plus minus the square root of b squared minus 4ac all over 2a. Alright, so there is the quadratic formula. Now, this is your a, 1 is your a, negative 2 is your b, and positive 2 is your c. Remember, never use the quadratic formula, students, unless the right side's equal to 0, which it is. So, for b is a negative 2, so negative 2. So I have a positive 2. Do you see that okay? There's a negative sign here. And I'm putting a negative 2 in. So negative is positive 2. Plus minus the square root of b squared. Square negative 2 and you get 4. Then I like to put negative 4 and then do AC in my head. So 1 times 2 AC, 1 times 2 is 2. And the denominator, 2 times A, 2 times 1 is 2. Alright, so next we have 2 plus minus Let's move on now to number 67. Okay, students, on number 67, first of all, it's written in standard form, and we have the right side equal to 0. So 4 is my A, B is my, 16 is my B, and 15 is my C. There's the quadratic formula. Let's slide it over here and get a little more room. And here we go. Negative, and you're putting a 16 in, so a negative 16. Hold on 1 second here, students. Alright, here we go. I'm getting tangled up in my chords here. Negative 16 plus minus the square root of. Now we have b squared, which of course would be 16. Grab my calculator here. 16 squared is 256. Alright, so 256 minus 4. Now a times c, okay? AC right here. A times c would be 64 times 15. All over 2a. Well, a is 4, so 2 times 4 is 8. Alright, now, next we would have negative 16 plus minus the square root of 256. We have a negative 4 times 60 would be a negative 240, okay? So 256 minus 240 would actually be positive 16 all over 8. Alright, so next we have negative 16 plus minus 4 all over 8, because the square root of 16 is 4. And now we can really break this down to two numbers. We have negative 16 plus 4 all over 8, that's your plus sign, and then negative 16 minus 4 all over 8, that's your minus sign. So negative 16 plus 4 would be negative 12 over 8, which would be negative 3 halves. And then negative 16, negative 4 is negative 20 over 8, which would be a negative 5 halves. So there's your two answers. I hope that we did that correctly. I have my concerns that we did not, but we did. That is correct. So I was concerned we made a little mistake somewhere. Alright, number 71. Alright, let's go ahead and get our quadratic formula up here. Now, notice it's written in standard form, x squared, x constant term. We have the right side equal to 0. So a is 1.4, b is negative 2, and c is negative 10. So negative b, put a negative 2 in for b, negative is a positive 2, plus minus the square root of b squared. So square b and you get 4, and then minus 4 ac. We'll do that in our head. 1.4 times negative 10 would be negative 14. Negative 14 all over 2 times a. 2 times 1.4 would be 2.8. Now, let's do our multiplication here. We have a negative times a negative, so we really have 2 plus minus the square root of 4 plus 56 all over 2.8. Alright, so next we would have 2 plus minus the square root of 60 all over 2.8. Now, let me look in the back of the book and see how they want you to write your answer on this one. Okay, we're going to leave it in square root form. So, here we go. $60 can be broken down, I'm sure, into, let's see, 4 times 15, which would give you a 2 out here. So 60 can be broken down into 4 times 15. Cross off the 4 and put a 2 on the outside. So now we have 2 plus minus 2 square root of 15. Now you cannot break down the square root of 15 anymore. However, you have one term in the denominator. You have 2 terms up here in the denominator, in the numerator, okay? You are more than welcome to move this decimal one place to get rid of it, as long as you do it to all these numbers up here also. So let me show you what I mean. I have a decimal here, even though I can't see it, and a decimal here. So I move the decimal one place, that's 20, plus minus, move this decimal one place, 20. Now you do not move the decimal inside the radical, because this is all one term right here. and move the decimal one place. That's 28. And now, outside number, outside number, outside numbers. You can reduce outside numbers as long as you can do it to all three of them, okay? 4 goes into all three of them. So this will become a 5, this will become a 5, and this will become a 7. Okay, 4 went to all three of those. So your final answer is going to be 5 over 7 plus minus 5 square root of 15 all over 7. And there it is, okay? Alright, moving on to numbers 75 and, let me look in my book here, numbers 75 and, that's it, 75. It says write as a power of 1, write the power of I as 1, or, I'm sorry students, write the power of I as I, or negative I, or 1, or negative 1. I'm just going to summarize that and say, just simplify it, okay? Now look guys, there is no need to write I 50 times, okay? Let's just kind of think this through for a second, alright? Look, every time you have I squared, alright, you have negative 1, correct? So I have a question for you. How many of these I squareds would we have to write to get I to the 50? In other words, let me break this down for you, make it really easy, okay? If I had I to the 8th, I to the 8th would be the same thing as what? I squared times I squared times I squared times I squared, right? Because I squared times I squared times I squared times I squared, you're multiplying like bases, write the base once and add your exponents. You guys know that, okay? So if I have I to the 8th, how many sets of I squared did I have? 4. You cut the 8 in half, okay? Look, if I had I to the 6th, that would be I squared times I squared times I squared. Got it? Because I squared times I squared times I squared is I to the 6th. So you took the 6 and cut it in half, and you have 3 groups of I squared. Got it? So if I have I to the 50th, cut that in half, I really have I squared times I squared dot 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 times I squared. I'm going to have 25 of these. 25 I squares. Got it? 25. So that means I'm really going to have negative 1 times negative 1 dot 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 times negative 1. How many times? 25 times. Now students, we know how this works. If you have negative 1 times negative 1 times negative 1, that gives you a negative 1 because you have an odd number of negative 1s, right? Well, if I have an even number like negative 1 times negative 1 times negative 1 times negative 1, that's 4. Well, negative times a negative is positive, times a negative is negative, times a negative is positive. So if I have an even number of negative 1s, it's going to give me a positive 1. So the question to ask yourself is, how many negative 1s do I have? Don't I have 25? I just said, I believe. So you're multiplying 25 negative 1s together. 25 is a what number? Odd number. And whenever you're multiplying these negative 1s together and you have an odd number, then it's all going to end up being a negative in the end. A negative 1. So there you go. I to the 50th is negative 1. Okay, moving on to number 79 and then number 83. And the directions for 79 and 83 is simplify the complex number and write it in standard form. Okay, so let's take a look. First of all, at 79. Well, guys, this is not too difficult. We have negative 1 times, or excuse me, we have negative I times negative I times negative I. That's really simple, students. Negative times negative is a positive I squared. Okay? And then this positive I squared becomes a negative 1 times a negative I. And I hope you're seeing this. I just broke it out step by step by step. Negative I is in the parentheses. So negative 1 or negative I to the third power is negative I, negative I, negative I. Multiply these two together, you get a positive I squared. Well, a positive I squared is negative 1. Now a negative 1 times a negative I is simply a positive I for number 79, okay? Positive I. And then lastly, number 83 will be a little more complex. We'll take it step by step. You're only cubing the denominator. So it's really 1 over 2I to the third power. So you really have 1 over 2I times 2I times 2I, which would be 2 times 2 times 2 is, let's first of all go with 2I times 2I is 4I squared times 2I, okay? Multiply these two together. Well, I squared is a negative 1, is it not? So 4 times negative 1, you really have negative 4 times 2I, okay? Which would then be negative 4 times 2I is negative 8I, okay? And so there we go. If you want to take this negative and put it out front, that's totally fine also. I believe the back of the book did that. I'm not sure if they did, but but students, you can put the negative here or the negative down here. It does not matter, okay? Alright, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.